I'm CK. Today we've got a module from Timo Rozandal, the FMP. It's based on the Yamaha FM voice chip used in lots of game carts, so that might make it interesting in terms of it might be a little grittier. I don't know if it's 8 or 16-bit, but we'll find that out when we turn it on. It'll probably be very interesting and has a variety of different sounds in it. So we'll put it together, put it in the rack, and see how it sounds. And I hope you enjoyed the video. Here's the stuff. Picked this up from thonk.co.uk. I'm not sure where Timo Rozandal is from. We'll look that up. There's a build document, QR code, QR standing for quick response, if you ever wondered. Let's look at the front panel first, as is our wont. So we've got octave and, okay, so this is carrier and this is modulator. So octave, multi, don't know what that's going to be, but it says BD level. That could be bass drum because they talk about bass drum. An edit button, looks like 2 LEDs, semitone, probably depth, and SN, signal to noise level, maybe. Decay, HH level, I do not know what HH stands for. And decay, and that, oh, that's hi-hat. Okay, so this is, if you're using it as a drum module, bass drum, snare drum, hi-hat, and tom. If you're using it as FM voices, then it'll be semitone, depth, decay, and so on. By the way, Yamaha has FM synthesis locked up, has for a long time. Many people are grumpy about that. Trigger and save. I don't know whether that's looks like a switch because that looks too small to put a jack in there. Trigger, control voltage, and out, so that looks pretty straightforward. Anything on the back? Panel for Timo Rozandal FMP. And there are 2 boards. We've got, this is FMP 1.3. And, gosh darn it, see that? It's all raggedy. I didn't smooth off the sprues from when they split the boards apart after they got their order of 8 boards in one block. So I'll do that right now, and I'll do it fast. And that's that. You don't have to do that. I just don't like having raggedy edges on my module circuit boards. So it looks like we have a big daughter card or whatever on there that's holding probably the FM synth chip, and they've got the number, I forget what it is. This looks like it's probably a timing crystal. Yeah, a timing crystal there, maybe 2 crystals, or maybe 3, because that's X1, and there's C13 and C14. Those are caps, those are capacitors, I'm sorry. So that looks like the timing crystal. And then there's another chip going here, some things to connect the headers, another chip here, power connector, probably a switch here, but I'm not certain about that. Actually, probably not, because it's got this rectangle. That may be a voltage regulator, a power transistor, whatever you want to call it, depending on how old you are. And here, same thing. Got some LEDs and a switch. That's a couple of pots. So that would be the octave and multi-pot. Pot, 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 pot. A couple of caps, some diodes. Pot, pot. More caps. Push button switch, it looks like. That would be trigger and save. And there's a 2-position switch for tone and drum. Board connecting headers. Couple of what? This is labeled as R1 and R2. I guess they're resistors. Gosh, this circuit software is a little interesting. The boxes for the resistors seem disconnected from the solder pads. Not a bad thing, you just have to realize that is actually where a resistor goes. Then we've got jack, jack, jack. And again, a couple more switches. And the board is, of course, through-hole plated. And I don't think we have anything more to learn about the unit from those right now. So let's see what's in the bag. And again, it's all paper, which is nice. Oh, even inside is paper, which is even nicer. Power cable. And here we've got programmable blue pill, which I assume is one of these Raspberry Pi, Arduino, whatever things. This is the board. Yeah, this is the one that goes up here. And they've already soldered the pin headers on it, so that's kind of convenient. And then we've got programming prongs there and an 8 megahertz timing chip, looks like. I don't know what this is. This could be... It's labeled as power, so it could be... Or that's a light. I'm not sure what that is. If this was AC, I'd call it a bridge rectifier, but it's not AC, so... Then we've got reset switch and some jumpers, and then USB to program, or I believe you can program it through there too. So we'll put that back in its bag. Now we'll look at the components in here. So this is some of the passive componentry, electrolytic caps, some of these blue diodes, I forget the part number on those, are typical big power conditioning caps. These look like 2 ferrite cores, inductors, smooth, clean up power a little bit, a couple of more caps. Couple more caps. That's not so interesting. And we've got a bunch of tiny 104s. These are low voltage 104s. Decoupling caps for the chips, I'm going to assume. In this bag we've got the Yamaha chip. That's interesting. And then a CD4. I think that's a op amp. The NE5532. I don't know what that is. And then those look like transistors. When I say I don't know what these are, that means that there is a 30% chance, no higher than 30, that I will look it up and tell you what it is. But that's not a whole lot. I wouldn't bet any money on that. There's a transistor and there's those chips. And that's the Yamaha FM synth chip. Again, I don't know if that chip is 8-bit, 16-bit, or whatever. And here's the resistor bag for resistor time for today, and a whole bunch of mechanical stuff. I'm going to dump the mechanical stuff in this bin and take a look at it, see what kind of quality componentry they got. Okay, some knobs. These are pretty cheap knobs. I've got a flat side to put on the index marks correctly, which is nice, but no set screw, no metal insert, so they're okay. Oh yeah, and here there's that big power transistor, LM7805, so 5 volt. But that's a lot of power. I can't believe this thing takes that much power. Thonkatron, Thonkacon, jacks, bunch of little switches, some shouldered red LEDs. Put a little background on that so you can see that. And a bunch of good quality pots. And they look like they're all 10K, but we want to make sure. And they're all 10K. And then over here, what did I just see? Oh, they're using the round hole precision, in quotes, IC sockets. I prefer the rectangular sockets, but that's just personal preference. Here's a little push button switch. So since we've got this, and I want to use it whenever I can because it's a neat little thing, this is my LED buddy that I built a little while ago, and it's just real handy. So we take the green LED, touch it to the two terminals correctly. You see the LED lit. Come on. The only thing is it's hard to show you. The LED's lit up, and it's 2 volts forward voltage, 6 milliamp current. This is at 5 volts, and a 470 ohm resistor. If you want to do inrush protection, let's see what the red one specs out to. 2 volts, 6 milliamps, 5 volts input power, and 470 again. So that's it. It looks like a pretty straightforward build, and some things are already done for us, which is convenient. So I'll get the soldering iron heated up, and we'll put this beast together. So we got the soldering iron heated up, but there was some other stuff in the bag that I neglected to show you. There are a list of components and their locations on what appear to be stickers. Oh, but the Electro, read the manual, read the manual, read the manual, read the manual. It's probably because they want to make sure that you put the polarity right. And they also threw in a survey thing that I won't show the QR code for, just in case, that individually registered. Let's see what, and I didn't bring up the build guide because I was lazy, so I will do that right now. Get the iPad open and bring up the camera. There it is. And the build guide is yonder, and we're going to tap on it. Let's see what it says. Always a fun... Yes, oh, okay, so you're just going to take me to this page. Okay. Additional information. In other words, more stuff you can buy. Description. Build document. There it is. Only took like 3 clicks to get to it. Okay, looks like we've got a bunch of... No, I'm not interested in Google Docs. I appreciate your effort. Looks like we've got pictures for everything, every step, which is great. And the next thing, I'm going to take a look and see if there's any calibration. Oh, they actually expected the boards to be together. That's interesting. I'm going to see if there's any actual calibration. I do not believe there's any calibration on this, but we will see. Not seeing anything yet. Oh, they're just showing the dimensions. Nope, no calibration. So it's just basically put stuff on the board and solder it, which is A-OK. So I won't even really have the build guide with me because it don't matter. This looks like they're stickers. They are. They're adhesive backed. Huh. I guess you could stick them on the bags. So we will start with our favorite, which is resistors. Get that done first. Make sure we've got everything out of the bag and get the bag ready for recycling. And okay, that's resistors B. Where's resistors A? Did y'all see me? Oh, there it is. It's stuck to the back. There we are. I was wondering because I had a 4 sheet, a 4 string, and I didn't see a 4 string on the thing. This is R1, R2, and so on. So what we'll do, which is typical for how I do resistors, because there's not much to talk about with them. First thing we'll do is we'll take a look at the value of these. These should be 1K, and they're coming in at 0.9999. That's great. So this will start with R1. So first we'll take a look and see. So there's R2, there's R3, which means we have no idea where R1 is. Again, since they assume you're building this part with the boards together, the ordering might be a little wonky. Don't see him there. Come on, where's R1? R2, R3, R9, R4, R5. There's R1. So because of the way this circuit board layout software worked with the leads so far away from the body outline, see how close that is to the edge? That's interesting. I don't know how much we bend the leads in. I'll start with a couple of millimeters on each side past. That's a little too much, so I will want to bend the next ones in a little tighter. Now we'll do one live to see how this board takes solder. Oh yeah, very nicely. See how it weeps through, weeped all the way through the plated holes, which is excellent. So that's it for live. Now I'll do the rest of the resistors with no commentary and in fast playback, probably with some of it clipped out, because it is time to enjoy resistor time. That's resistor time for this kit. Not too bad, not too onerous. Not like, say, a Buffaco build with 15,000 resistors. We'll do the diodes one at a time, one type at a time. Now we're going to put the IC sockets on, and we'll make sure we have the right pins, and we'll have the notch going in the right direction. And that's too many pins, so that does not go there. Are you sure? Where does that one go then? Oh, it goes over on the back side here. I see. Double check this just. Yeah. So put that there on the back side and find my solder. Where did I put my solder? There it is. And we will solder one pin. Make sure it's flat. It is. And we'll catch the rest of the pins on the next after we get the other two sockets on. Okay, now we'll go back to this side of the board and put three caps and the crystal on this side of the board. Where'd the crystal go? There's the crystal. Crystals are not polarized. This is 3.5 megahertz. And then we'll do, trying to see which ones we want. The 18 picos and 100 nanofarads. So we'll do the 180s first, and they're going to be hard for my eyes to see. So these are 104s. Solder these little fellas down, and I think we'll be done with that side of the board. Now he'd like us to do the voltage regulator. We are going to lay it flat, so we're going to put the pins in, not all the way to their shoulders, and just lay it flat. And maybe coax it down a little bit more. We're going to put all their caps. Yep, we're going to put all the rest of the caps on now. So we've got all our 100 nanofarad 104s. We'll scatter them around there. They're often near the chips because they add a little power conditioning or decoupling, however you want to phrase it. And it looks like we've got some on this board also coming off the pots. That's kind of interesting. I rarely see that. There's all the 104s. And we'll do this. This is a, this goes at C21. And now we'll put the electrolytics on, and then we've got this. This is what? This is a regulator, wasn't it? No, that's a transistor. These are 47 microfarad, and they will go in C19 and C20. And we've got this little 10 micro RAM, 10 micro. And that goes in C15. Now I'll clip these in a minute. I'm actually looking at this transistor. It's a negative, but I don't know where it goes. I'm looking at the picture and you're seeing my... Oh, it's over here. What's over here? Huh. It's on the controls and pots board, which is a very unusual location for a transistor in my experience. Now I also want to put the power header on at this point. And the power header is keyed. And there's a mark on the board to show that it's keyed. There's also a line, heavy line here to show that the red stripe should go there, which means the key should go like that. And it does, so we are safe to solder the power header on. And that is all the general purpose components. We'll go on to the daughter board and the pots and jacks, but not right now because the cats want to eat. So, catch ya in a little bit. Okay, the next thing we're going to be doing is we're not going to be taking this directly onto the board, which I kind of, take a look at this. The pins are kind of big anyway, so what the guide says is instead we'll put these pin headers on, if I can get them on there right. And I'm actually going to put the board a little bit in it, because that'll keep them all aligned while I solder them down. And that is the direction it'll go. The USB port faces that away. Now we're going to put a nylon spacer here. Where is that? That's probably in the small mechanical bag. And I can dump that in here since we've gotten rid of all the electronic components. Or it's not in there. We do have a metal spacer, but I'm not seeing a nylon spacer. Double check everything again. Let's see what those are. Well, I'm gonna assume that in lieu of a nylon spacer, we'll use this metal spacer. Got to put it on now because when we put the microcontroller back on there, won't be able to get at it. Where's my tweezers, for crying out loud? There we go. Put that on there. That will, of course, eventually mate like so. Because this obviously faces outward because it's got the power connector that way. Now we're going to do the other headers, and we got to cut them, but apparently we don't have to cut them because he's already pre-cut them. I'm seeing where he wants these to go just to be sure. And clearly these go like that because obviously the pots and so on are going to be on this side. So even though the silk screening is a tad misleading, just use your brain and you get it figured out. And I'm going to do putting all the pin headers in there. It doesn't really matter which side is the female side and which side is the male side. Some of us prefer to do it one way, some of us prefer to do it another. I'm going to do this because there are 4 of them. So I'll put the little male sides in too. Just lightly. I'm not pressing them firmly together because you really don't need to. You're just trying to get a... well, that one went in, so if that one went in, they all got to go in. So never mind what I just said. Now we'll take the other one and make sure we've got it right side round. that. Line those up with my tweezers again. And now we'll go to the other side. That one's good. This one is not yet good. And now they're all good. And just for fun, take a little clamp, kind of clamp it to keep it together, even though I could put the screw in there, but I'm not gonna. And I haven't remounted this because I don't want to do that right yet while I'm still manipulating the whole board. Oh, he does say put the other screw in instead of clamping it. The build guide author suggests putting the ICs in now. I think I will wait on that. Just because I'm still working on the boards, and if I can leave the ICs out to prevent anything untoward happening. But now we're going to put all the pots and so on. And as we saw earlier, they're all 10K, so we don't have to worry about their orientation. Now the switches, we've got two switches. One is a single pole double throw. Put that in there because that will go with edit A, B, and off. And this switch is tone and drum. And I always like to face the switch down. That's only me. It makes no difference to anyone but me. Now the jack, actually I'm going to put the LEDs here. Let me look at the color. I have to make the color a little bigger. And positive side is marked for them. And that's going to be a red one over there. Oops. Polarity is different. Don't assume positive is always up, because it isn't. Now, take the front panel and manipulate that into place, which is always the most fun thing of putting one of these together. And the switch is, there we go. Got to get low enough that that push button goes through, so I'll sort the pots back down again. Now this is tight. So what I'm going to do to help myself is, again, grab my little clamp, give myself some tension there. Of course, it's uneven tension, but that helps us slide everything down. Now the trigger button is not quite lined up, so where's my pointy thing? Get my pointy thing in here and get that through. Can I? That's a little This one hasn't come in. There we go. Here we go. Everything's flat. And the trigger button is accessible, which is great. So what I'm going to do here is I'm going to solder this octave pot down, just one of the legs right now, in case I want to change things around, and put, I let it slide, didn't I? Everything's back together again. So I did the octave, as I said, so I'll put a panel nut down on that. And as usual, I don't care about putting washers under those. So if you see me do that without putting washers on it, that is deliberate. You probably will want to put washers on it. I don't, because I'm a curmudgeon. So I'm going to do this socket. And do the same thing with it. Put its panel nut on. And I still have not done anything with the LEDs. I won't for a little bit. So that's all that. Now I'm going to solder everything but the switches, because as you can see, the switches have a little bit of travel in them. And I will probably do those first. Now that I think about it, I'm just going to lay this piece of foam on them to keep them pressed flat against the circuit board while I'm soldering. And I will do as I've done with sockets and pin headers, and just put a little bit, do one pin on each switch. Again, I got to make sure this is fully engaged, and it is. Okay, now everything is tight, nothing's wiggling, the switches are in the right places. Now I will feed the LEDs through the front panel, if I can see what I'm doing here. There, that's one. Well, I'm thinking now. Hold on, let me get two of these in. As you can see, they stick out quite a bit. Let me zoom in a little bit. Oh, that didn't do much good, did it? I can't actually see what the heck's going on. There we are. They stick out quite a bit. Zooming back again. Moving the camera. I don't know if I like that. I think I want them flush against the panel. So what I am going to do is get a little masking tape, painter's tape, whatever you want to call it, and put it right there. So it'll be flat against, flush with the panel. We'll do this on the other side too. And I'll do this down on the lower parts also, but I won't do that quite yet. Actually, I probably will. I may as well do it for all of them at the same time. I actually looked in the build guide, and the author of the build guide, also uses tape to put those flush. I just hadn't read ahead in the build guide because didn't particularly care. Now I'm taking the front panel back off so we can screw together the two boards. He does mention that you can put the spacer on the pots and jacks board and then you don't have to do this, but I didn't. The only problem will be if we get the LEDs jostled around, then we may have to fight that together. But now we'll put the chips on. Now before I screw all this back together, I'm going to go over, and before I put the final board there on, I'm going to look at every solder connection to make sure they all look appropriate and not bridged or shorted in any way, and also that they're all soldered. I have done two things that you might think you'll never do, but I have, number one, missed some solder connections, which obviously can happen pretty easily, but I've also forgotten to put chips in and turn power on and nothing happens, and then you look and you say, oh, I forgot to put the ICs in, and you feel kind of silly. But feeling kind of silly and fixing it is better than feeling kind of silly and not knowing what's going wrong. So order of troubleshooting for me is solder joints, look at all the solder joints. Diodes, make sure all the diodes are in with the correct polarity. Transistors and voltage regulators, if there are some, make sure you haven't gotten them backwards with the flat side facing the wrong way. And then from there you have to, those are what I'd call very common mistakes. I gotta get that right, there we go. Let's get all the LEDs to go through well. And all the LEDs went through well. And everything is down. Now for the next exciting part. Oh, by the way, I think I said this, but I'll say it again. The author of the build guide also doesn't use washers on the potentiometer panel nuts. So I'm going to put all these panel nuts on in fast motion. Now we'll put the knobs on. Turn all the, turning all the pots counterclockwise is less important on this one since there's the half round in here that allows you to get the indexing right without any real worries. There's no, oh, I see. I was wondering what those were. Okay, we'll get to this in a sec. Gosh, see, they take a beautiful concept like these half rounds to make sure you get the indexing right, but then you have to put these little caps on the knobs to point where you want them to go, and I'm going to mess that up. Well, it's not too bad. They seem reasonably okay. It's hard to get that trigger switch between the pots and tone versus drum machine and the edit and off, but we can work with it. Now we'll put the power connector on for the last time. Double check all our bags to make sure we've put all the parts on we need to. And that's it. That's the front. It's the side. It's the back. The other side. The top and the bottom. Now we'll put it in the rack and see how it sounds. So I just went through the whole demo and then realized I hadn't turned the camera on. So we'll do it again. So let's start with tone, and I'm going to fire up, I'm triggering with my LFO. So this is tone mode. So the different sounds you can get out of it. Make decay shorter and it gets very percussive. So it's kind of interesting. I'll speed it up a little bit. And I'm going to take CV over to my I can't get the I'm not getting good CV response from my MIDI keyboard. A little bit more. I really have to take CV scale up really high. Put some feedback in. So that's what it's doing there. Let me flip over to drum. And now bring the sound up again. So there's the bass drum. Now we'll bring up the snare. Now we'll bring up the hi-hat. Bring in the cymbal. Actually, let's hear what the cymbal sounds like by itself. Now we'll bring up the tom. Bring the bass drum back up. Bring everything up. Take feedback out again. That sounds kind of nice. Then we can flip back to tone. to drums. It's just the bass drum. Let me take the, you don't have a decay to control when you're in drum mode. You just get what you get. So that's it. It's got some interesting sounds. Obviously, it's as he describes and as the manual describes, this is from a game, this is really a game chip, so that's what you're hearing here. There's not a lot of modifications you might be used to on a VCO, like synchronization, frequency modulation, and so on. And there's no, the internal envelope is very short, and putting it through a VCA, I don't think it'd be really effective. I think you just got to go with this and I think the best use for it, in my opinion, is as the drum module, because at least it's got all 7. Now, there again, you're triggering them all at once. You can't have 4 beats on the bass drum and 8 on the snare, for example. So you got to live with that. So it's limited in some ways, but it's got some interesting sounds, and you can do some editing and saving if you want to. And as you saw, it was a pretty simple build. So it's an okay unit, and I hope you enjoyed the video.